Okay, on page 99, I am doing problem number 3. So this problem asks you to explain a number of puzzles using a supply and demand model. And I already did A in class, but I'm going to do it again just so you can see the logic in it. And so here we're talking about, in part A, we're talking about the market for lobsters, both supply of it and demand. And before I even start looking at the problem, I'm going to draw and set up my supply and demand model. So I have price on the vertical axis, quantity on the horizontal axis. I'm going to draw an upward sloping supply curve, which denotes the fact that we believe our suppliers are profit maximizing. When prices increase, they will bring more lobsters to the market. And then I also have a downward sloping demand curve, which reflects the fact that reflects our law of demand, that as the price of lobsters decreases, we expect our consumers to purchase more of them. All other factors that might influence their purchase held constant, ceteris paribus. So this problem is asking us to explain the fact, and before we even think of our supply model, let's think about the intuition. It's saying that during the summer peak lobster harvest season, so at a time when harvesters are going to harvest a lot of lobsters, lobster catchers are going to catch a lot of lobsters, people are also wanting to eat a lot of lobsters. And so you get this kind of counterintuitive result, which is that at a time when people are eating a lot of lobster, demanding a lot of lobster, the prices of lobster actually fall. Remember, our supply and demand model typically shows us that if the demand for something increases, then the price of that thing should increase. But before we start graphing, let's think about the logic of this. If somebody were to come to me and tell me that this was happening in the market, I think one of the things that I would arrive at is that it might be possible that suppliers are actually catching so many lobsters that it's actually countering the effect of the increase in demand. And that's exactly what we can capture with this graph. So let's first graph the fact that in the summer, people's tastes change. They increase their demand for lobsters. That's a shift in our demand curve. Now let's say that at the same time, so let's think about first, actually, before I shift the supply, let's actually consider where our initial equilibrium was. Our initial equilibrium was where the original supply and original demand curve intersected. And if so I'm going to denote this as E sub 1. And I'm going to come down to the horizontal axis and show that this is exactly the point where the first demand curve, the quantity demanded of the first demand curve, equals the quantity supplied of the first supply curve. And this is exactly what defines equilibrium. And that equilibrium point also has a corresponding equilibrium price. It's the price at which consumers and suppliers agree. Consumers will consume the amount of lobsters that suppliers are willing to bring to the market at that price. So now let's go back to the summertime. In the summertime, we saw a shift of our demand curve to the right, D sub 2, which reflects the fact that people want to eat more lobster. At the same time, the problem tells us that we are harvesting many more lobsters. So let's imagine a big increase in the supply of lobsters, so that this is our new supply curve. Let's take a look at where our new equilibrium point is. Well, our new equilibrium point is going to be where our new demand and our new supply intersect, and that would be at this new green dot here. And actually, let me do it in a different color just so you can keep track. So it would be this blue dot right here, and I'm going to denote that E sub 2. And now let's take a look and see what has happened to our quantity demanded for our new equilibrium point. So this is again the point where the new quantity demanded equals the new quantity supplied. This is our new equilibrium quantity. So we have more lobsters demanded and supplied to the market. Now let's shift over to the vertical axis and see what is the price that corresponds to an increase in both the demand and supply for lobsters in the way that we've drawn it. And we can see here that we're at our new equilibrium price, which happens to be lower than our original equilibrium price. So this is exactly explaining the intuition that I just explained in the beginning, which is that in the summertime, people want to eat more lobster, but at the same time, catchers are able to catch a lot more lobster, and that increase in the supply of lobster offsets any increase to the price of the lobster that would have been occasioned by an increase of demand. Moving on to problem B. So in problem B, we have we are considering the market for Christmas trees. And so I am going to consider, before I even really look at the problem, I know I'm going to be considering equilibrium and supply and demand, so I'm going to draw my supply and demand model where I have quantity on the horizontal axis and price on the vertical axis. I'm going to draw a hypothetical supply curve that slopes upward from left to right, reflecting the fact that our suppliers are profit maximizers. As the price of Christmas trees increases, they're going to want to bring more Christmas trees to the market. I'm also going to graph a hypothetical demand curve, which is downward sloping from left to right, which reflects the fact that our consumers want to purchase more trees the lower the price of Christmas trees, and correspondingly they're going to want to purchase less Christmas trees the higher the price of Christmas trees. I am going to assume that we begin at this point here, the intersection of the supply and the demand curves. And this place where the quantity supplied equals the quantity demanded when supply intersects with demand is equilibrium. I can tell generally what my quantity demanded is by coming down to the horizontal axis. So I have quantity demanded here, which also happens to be quantity supplied, and that is exactly what should happen when we're at an equilibrium. So this is my equilibrium quantity, the first one. And there is a price that corresponds to this quantity. And so just to give a little intuition, this is the quantity and price where suppliers say, okay, at this price of Christmas trees, say $50 a tree, I am willing to bring a certain quantity to the market. And that quantity happens to be exactly the quantity that consumers are willing to purchase at that price of Christmas trees. That is what an equilibrium is. So now this problem 3b tells us, again, another puzzle, that even though there is less demand for Christmas trees after Christmas, the price of a Christmas tree is lower. So the way we can see this on our supply and demand curve is, let's imagine that it is now after Christmas. And after Christmas, let me do this in a different color. After Christmas, people reduce their demand for Christmas trees. Christmas is now past, so there is a shift in the demand curve to the left. As a result of this shift in the demand curve, we see a new place that our quantity demanded and supply intersect, and that is at this blue dot here. And this is our new equilibrium, because this is where the supply curve and the demand curve intersect. If we come down to the horizontal axis, we will see that we have a new equilibrium quantity and a corresponding new equilibrium price. And this is exactly what this problem says, that after Christmas we have less demand for Christmas trees, so that there are less Christmas trees on the market, and at the same time we have a decrease in the price. Moving on to part C. So in part C, we are talking about the market for tickets to Paris. And the problem says that we have this event happen, that at the end of the summer, and here it says end of school vacation in September, the price for tickets, round-trip tickets to Paris, falls, which we would expect because students are going back to school, and so there's less demand for a trip to Paris, and so the price will fall. But the problem adds a little bit of a problem in this result, which is that at the same time, in September, there's worsening weather. You can imagine that it's starting to become colder and maybe there's more storms. And because of that, the cost of operating flights to Paris increases, so that we would expect the price of tickets to Paris to increase. So just before we even start to graph our supply and demand model, let's think about this intuitively. Students go back to school, the price falls, but the weather gets worse, and so the cost of flying to Paris increases. Well, if somebody came to me and said, I have this situation and this is what happened, and can you explain why? Well, I think one sort of thing that I would eventually arrive at is that it's possible that the dip in demand for flights to Paris is too large for the increase in costs of flights to push the price up. And so the increase in the cost of operating the flights is not outweighing the need to keep ticket costs low because you don't have enough demand. So let's think about, as long as that makes sense intuitively, let's think about representing this graphically. So if we represent this graphically, I'm going to start as I usually do, with quantity on the horizontal axis, with price on the vertical axis. I'm going to draw a hypothetical supply curve that increases from left to right, reflecting the fact that my suppliers are profit maximizers. And I'm going to draw a hypothetical demand curve reflecting the fact that my consumers are obeying the law of demand, that when price of tickets to Paris decreases, they're going to demand more tickets. And conversely, if the price for tickets to Paris increases, they are going to demand less. I'm going to imagine that our market starts at this original equilibrium here, where the quantity supplied equals quantity demanded, where the supply curve intersects the demand curve. And I can see that by coming down to the horizontal axis and seeing that this place where it hits the horizontal axis is both where quantity demanded is also quantity supplied. So that is exactly an equilibrium point. And this is the equilibrium quantity that corresponds to that equilibrium point. And if I move over to the vertical axis, I can also see or denote the price that corresponds to equilibrium. That is the equilibrium price. So in other words, for intuition, this equilibrium is a place where suppliers have said, okay, at this price, say, I'm making this up, $400 a ticket to Paris. Suppliers, the operators or owners of Air France, decide, okay, at $400 a ticket, we will sell 10,000 tickets. And consumers or potential travelers looking at the price of tickets to Paris say, okay, well, at $400 a ticket, we are willing to purchase 10,000 round trips to Paris. Those two preferences exactly coincide. $400 a ticket, that's the equilibrium price. 10,000 tickets sold is the equilibrium quantity. That is what an equilibrium is. So now this problem says that when school starts, so in September, when the school vacation is over, we have the price fall because people go back to school, and so the demand for flights to Paris decreases. So we have a new demand curve that is lower than our original demand curve. It shifts to the left. And at the same time, however, the cost, the increase in the operating cost of tickets, the increase in the operating cost of flights increases so that supply is reduced. It becomes more expensive because of the bad weather. It becomes more expensive to send flights to Paris. And so supply is reduced a bit. Now we consider, where is our new equilibrium? And notice the way that I've drawn this. I've decreased demand a substantial amount, and then I haven't decreased supply enough. And that corresponds to what I originally said, that the intuition of this answer is possibly that you have so many students going back to school that supply is not cut down enough by the increase in costs, so that you still have a lower price. So now if I look at my new equilibrium, where this blue dot is, I see a place where the new supply and the new demand intersect. If I come down to the horizontal axis, I see this is the new place where quantity demanded equals quantity supplied, which is exactly what a new equilibrium is. And if I move over to the vertical axis, I see that I have a new price that corresponds to a new equilibrium. And if I look at what happens, I see that indeed the quantity supplied and demanded has decreased. The equilibrium quantity has decreased at the same time that the equilibrium price has also decreased. And that's exactly what this problem has told us happened.